Dear students, let's start lecture number 4 on the topic substitution and transposition techniques of the course network security. Uh, let's start with outline. This is our outline. First, we will revise our lecture number 7. Then I'll go through block cipher, and then I'll technique one more technique as we had studied in our last class, one of the techniques regarding substitution technique, but today we will taking one more technique on one time pad, which is called one time pad or Varnam cipher. And I'll also explain transposition techniques, and I'll take an example on it, which is called as columnar transposition technique. So let's begin with a revision of lecture number 7 on the topic substitution techniques and types of plain text processing. So we studied that in symmetric cryptography, if sender wants to send anything to receiver, what sender does that sender creates message, then apply encryption plus key on it to create cipher text, and then the cipher text travels along the network and reaches the receiver, where receiver perform decryption and key. And this is the key, same key which is used by the sender for creating ciphertext. So this key will be travel along some secure communication channel, as we as I had shown in my previous lectures. So, and then after applying the process of decryption or deciphering, you will get the message, plain message or readable message back. So this is we call it as a symmetric cryptography technique. So then we studied a cipher method. This is one of the method in substitution technique. What were the substitution technique? In substitution technique, each letter of the alphabet is substituted with a different letter, symbol or a number. And in Caesar method, every letter of the alphabet is replaced with the letter 3 away. So for example, you can see here, let me have a spotlight. um, yes, so these are our alphabet from A to Z, and I have numbered them from 0 to 25. And uh, I have replaced each with the 3 away letter. Like for example, A is replaced with D, as D is 3 letters away from A, and then I replace B with E, as E is 3 letters away from B, and so on. When we reaches X, so when X is replaced with A, as we are taking mod of 26, so you will get the A back again, and replace Y with B, as this is 3 letters away when you take mod 26 of that, and C is replaced with Z. Z is replaced with C. So you can see here in this process, like for example, you have plain text, and when ciphertext is created, this is the formula through which the ciphertext will be created, like how the encryption will be done. So 3 letters away, this is a key and the plain text, and P plus 3 mod of 26. This is the formula for creating each bit of your ciphertext. And when it reaches the base station, this is the formula of decryption, where D3 is the key, as in Caesar, each letter is substituted with the 3 letter away. So 3 C and 3 minus C mod of 26, as we normally says that on sender side encryption is done and reverse process. So this is the reverse. On the sender side you have P plus 3, and on the receiver side you have a cipher minus 3. P means plain text plus 3. Each character in a plain text is replaced with the 3 letters away. And in a cipher text, C minus 3 means cipher minus 3 letters back. So you will get the original text back. So this was the example of Caesar method. Journal Caesar method, what was the journal Caesar method? A shift may be any number. Like in Caesar method, we have taken 3 as our shift or a shift. Normally we replace each character in a plain text with the 3 letters away. But in journal Caesar method, you can take any shift within the range from 1 to 25. You can take any one. So how the cipher will be created? A plain text plus key. This depends on you that bit which number you want to select within the range of 1 to 25, and then you will take mod of 26 for the encryption, and for the decryption you will be using the same key which you have used for the ciphering, and then you will get the original text back using this formula. Uh, as far as cryptanalysis of this kind of techniques like substitution techniques are concerned, so if a brute, they can brute forcefully, cryptanalysis can be done very easily on them, because you know that if you apply different possibilities you will get the original text back. Now, secret key encryption and decryption. So there are some other techniques which are a bit harder to crack. What sender does that it uses encryption to encrypt the message and send the message to the receiver, and then what receiver does that receiver decode that message. How does the receiver decode the message? Definitely the sender needs to send the key to the receiver, otherwise he will not be able to get it back, because the key is the most important factor of deciphering. So this, and one important thing is that that key must be sent on a secure channel in order to save it from intruder. Most encryption algorithms use mathematical formula and encryption key to encode the data. Encryption key is very large. Normally, it is assumed that take a large number of key. So if your key is longer, so it is assumed that your data will be more secure. And most encryption algorithm uses key length between 40 to 128 bit or more. Symmetric or private key encryption uses single key or a number. Both the sender and receiver must know that key. And decryption, DES, data encryption standard, is most widely used standard for symmetric encryption. I'll discuss this in my today's lecture while studying block cipher, because each sender and receiver would require same key. This type of encryption is basically used by government entities. It is really used for e-commerce transaction over the network. Requires a secure way to get the keys to both parties. This is the most important factor, that the key must be sent to the receiver through secure channel. This was the assignment which I have given to you. I hope that you have done this assignment. Please, if you have completed this assignment, so please share with me on KCMS or WhatsApp. Now, this is stream cipher. These are the types of plain text processing. Like in a stream cipher, as its name indicate, that the process of process of ciphering. Process of ciphering is performed on each bit. So, for example, if the sender wants to send anything to the receiver, so what sender does that it creates a message and then key is applied on each bit of the plain text, and then it will be sent to the receiver. So here at the plain text, XOR operation will be performed, and on the receiver and the same XOR operation will be performed to get the message back. So how it will be done, I'll explain with the help of demonstration. You can see here that here you have M1, M2, these are the messages, and these are the keys generated by the key stream generator. Now you are performing XOR operation on message and each key and get the ciphertext. And when it reaches the receiver side, you have a ciphertext, and now the same keys will be XORed and get the original message back. Now you can see here, this is an example that, for example, if the sender wants to send 10110110, and this is the key which is generated by the key stream generator. So here the XOR operation is performed. I hope that you know the XOR operation. In XOR operation, if you have the same bit like 00 or 11, so this will be 0. Otherwise, if you have a different bit, so this result will be 1. So as they are different, so result is 1. They are different, 1. They are same, 0. Same, 0, same, 0, different, 1, different, 1, different, 1. And when it reaches the base station, the same, when it reaches the recipient or a receiver for deciphering this cipher text, so the same key will be applied with the XOR operation. So you see that we will apply as they are similar, so you will get 0, different, 1, different, 1, similar, 0, different, 1, similar, 0, different, 1. So if you compare the result of the recipient, this was the same as sent by the sender. So this is how stream cipher works. Now let's start with lecture number 8 on substitution and transposition techniques. Before starting our today's lecture, I gave you a brief overview of the block cipher. As we have studied in our previous lecture, we have studied stream cipher. And see what the stream cipher was, uh, uh, that the processing was done on each bit, whereas in block cipher processing will be done on blocks. So what what the sender does, that it creates a block equal size of block of its message. Like for example, you can see here 64, 64. These are the blocks, 64 bit of each block. This sender divides, and then key generator, you can select any key out of these keys like 40, 56, 64, 128, whatever you want to select. You select a key here, and then you will when you will uh, apply these key on this block, you will get the ciphertext. You can see here this ciphertext. Now this ciphertext will be moved to the receiver, where the receiver will use the same key which is used by the sender and get the original message back. Here we have taken the example of DES, like data encryption standard, which I have explained in my previous lecture. So normally DES uses 64 bit of block and 56 bit of key. So I have taken example of DES, where the sender divides the message into 64 bits of block each, and then apply 56 bit of key on it to get the ciphertext, and then the ciphertext will be sent to the receiver, where the receiver uses the same 64 bit of blocks and apply the same key which is applied by the which was applied by the sender to get the original message back. So this is the block cipher. Now this is one of the substitutional techniques, as we have studied one techniques in our last lecture, which was Caesar Caesar technique or journal Caesar technique. So today I am considering one more, and that technique is called one time pad or Varnum cipher. This is one of the substitution techniques. So before starting this technique, you number each alphabet from A to Z from 0 to 25. Now, for example, if a sender wants to, I have created two blocks. So you can say this is gray block as a sender and this green blocks as a receiver. So what sender does, for example, if the sender wants to say good to the recipient or a receiver, so what we do, that we will replace each character. Let me have a spotlight. So you can see that I have replaced G with 6. You can see that G is at the 6th place of alphabet if you start from 0. So G is replaced with 6, 0 is replaced with 14. As you can see that 0 is at 14th place, and again you have a 0, so this is again on the 14th place, and then you have a D, which is at the 3rd location of the alphabet. So I have replaced with 3. Now you can see any random key, like I have selected one HVZQ. You can select anyone, and then you will get the corresponding number on that. Like suppose at uh, H is at 7, and V is at 18, and Z is at 25, and Q is at 3. So you can use any of the number. You can then write that number here, and then you will add these two, like 6 plus 7 is 13, and 14 plus 18 is 32, and 14 plus 14 plus 25 39, and then 3 plus 3 is equal to 6. Now you have added the plain text number with the random key numbers, random key numbers. Now you will subtract, and how the subtraction will be done, this is very important to remember, that only those characters will be subtracted which are greater than 26. For example, this is 13, so this is not greater than 26, so there is no need of subtraction. For the 32, as this is greater than 26, so we have minus 32 minus 26, so we will get 16. This is again greater than 26, so what we did, that we minus and get the 13, and this is less than 26, so there is no need of subtraction. So now we will get the character located on each number. Like on 13 we have a N, on 6 we have a G, on 13 we have a N again, and on a G on a 6 we have a G again. So now this is our cipher text, and this will be sent to the receiver. When the receiver receives this will minus with the key. As you know that in this case we have performed addition, but on the receiver side we are minusing from each number of the character received. So for example, you have minus it, like 13 minus 7, 6. Now you have minus 18 plus 6, means you have minus 12. In this case, if you have a minus, then you will add 26 and you will get 14. So if this operation performed, you will get the 14. Now you need 14. So you see at the 14th position, you have a O. Now minus 3 plus 6 means 3, and you will get D. So this is how receiver perform operation on this in a case of one type pad and get the original text back. I have written note here that if a number is negative, and as I mentioned here, then minus 18 plus 6 means minus 12. In that case, only 26 will be added to the number to make it positive. Otherwise, no need of addition. Now, transposition cipher. Transposition cipher, they are different from the substitution cipher. Different kind. This is a different kind of by performing some sort of permutation. In substitution, you substitute letter with some other letter, but in transposition cipher, what you do is change the position of the original text. Like for example, if a sender wants to say Cohort University of Science and Technology, so I have taken a table of 6 by 6. You can take table of any size, but I have taken the table of 6 by 6 as I thought that I can manage this information easily in that. So, and then I have selected key like 541 2 3 6. You can take it randomly, but one thing, remember that the size of the key must not be greater than the size of the table. As I have a 6 columns here in this table, so I have a 6 bit of key here, and each number is representing some column. As this technique is called columnar transposition technique. So we will be presenting our cipher in the form of columns. So you can see here that first of all, I'll take, you in the key, you see 5. So first of all, I'll take column number 5 here. So column number 5, you have T, R, F, C, H, Y. You can see I have written here. Then I'll take column number 4. So you can see here, this is a column number 4, like E, E, O, N, C, G. This is column number 4. And then I have a column number 1, then column number 2, column number 3, and finally column number 6 to get it cipher text. Now this text will be sent to the sender, and what to the receiver. And what the receiver does, that receiver receive this cipher text plus this key. So he will then understand that how he will have to decipher it back and get the original text. So this was a transposition cipher. I hope that you have understand that. This is sources which I have considered. You have go through them and find them more about these techniques if you find any problem. If you have any question, you can ask me through KCMS or WhatsApp group, or you can email me. I'll be more than happy to answer your question. Uh, Thank you very much. With that, we reaches end of this lecture, and I'll come with the lecture number 5 next time. Allah Hafiz.